Since I need to solve for p, I note that the p's are intermingled in the numerator and denominator of this fraction. So I start by finding the LCD of both the sides of this equation. And since I have q over 1 on the left hand side, the LCD of 1 and 2p minus 5n is just 2p minus 5n. So I start by multiplying both the sides of my equation by 2p minus 5n. So I get q times 2p minus 5n equals 8p over 2p minus 5n times 2p minus 5n. Now the advantage of this is that I can cancel 2p minus 5n from the numerator and denominator on the right hand side. As for the left hand side, I'm going to multiply the q to both the terms inside the parentheses on the left hand side. So I get q times 2p is 2qp and q times negative 5n is negative 5qn, and on the right hand side I just get 8p. Once again, remember we're solving for p, so my goal is going to be to treat p like the variable and everything else that does not involve p as a constant. So what I'm going to do is I'm going to take the term that all the terms that have p on the same side and any term that does not involve p to the other side. So in order to do this, I'm going to bring 8p over to this side, so I'm going to subtract 8p from both the sides of the equation. And to bring negative 5qn to the other side, I'm going to add 5qn to both sides of the equation. This means that my equation now becomes 2qp minus 8p equals, remember we took 5qn over to the other side and it became positive 5qn. Since on the left hand side you have two terms that involve p, you can factor it out of the expression, and so you get p times 2q, and when you factor out p from negative 8p, you get negative 8 equals 5qn. To finish off and find the value of p, I'm going to divide both the sides by 2q minus 8. And then on the left hand side, I can cancel 2q minus 8. So on the right hand side, I'm left with p equals 5qn over 2q minus 8. And that's the answer to the question.